you doing? It's MrDoTheMath here, and today we're going to talk about the area of sectors. Right. So, we already talked about arc length, right? Arc length was focused around the portion of the circumference. Today we're going to look at the inside of the circle, right? So, first and foremost, we need to review what the area of a circle is. We talked about it before, right? The area of a circle is what? Yes, pi times the radius squared. Pi r squared, right? So if you have the radius, you square it and multiply it by pi, you have the area, all right? So say it with me. The area of a circle.
The area of a circle.
Pi r squared.
Pi r squared.
The area of a circle.
The area of a circle.
Pi r squared.
Pi r squared.
The area of a circle. Pi r squared.
Pi r squared.
All right, good.
Mr.
All
Patterson,
right, so you'll remember that. Mr. Patterson probably not so. All right, so the area of a circle is pi r squared, right? Circumference is 2 pi r. All right, it's 2 pi r. So one day I'm gonna have to make a song about that. If I could rap, I wish I could. But anyways, all right. So let's practice. So what if I said the radius of this circle here was 2.5? What would the area of this circle be? Yeah, area would be 2.5 squared pi. Right? And if you've been memorizing your perfect squares, 25 squared is... Who just said that? Yes. So, 625, right? Pi, right? But we have two decimal places, so it's going to be 6.25 pi.
I got 19.6. Right. Yeah, I got 19.6.
Did you multiply pi?
Yeah.
Yeah, so when you multiply pi in, yeah, so it's roughly 19.6, right? So both of these answers are good answers. 6.25 pi or 19.6, roughly 19.6.
So we can leave it as pi? Like, won't have to multiply that?
Yes, ma'am. You can leave it in terms of pi.
Oh. I thought you had to multiply that up.
I mean, but unless we specify saying like give like an approximate answer or something like that. But anyways, the area, pi r squared, right? Area of a circle, pi r squared. Okay. Oh, I can't wait till we get to surface area. All right, but now that we know the area of the whole thing, a sector is a portion of the circle. It's a portion, like it's a piece of the pie. That's what we can look. This is what we can think of, right? A piece of the pie, right? So whenever you try to figure out you can actually figure out the measure of like a pie, the area of a pie, by doing this formula I'm going to show you. All right. So so the area of a sector. Area of a sector formula. It's a proportion, just like we worked out before. All right, the proportion is the area of a sector over the area of the circle equals that central angle, right? The measure of the angle over 360. All right. So this is a lot like arc length, except we use area instead of circumference, right? We use area instead of circumference, right? Then from here, you solve for whatever we are trying to find, okay? So when you have sectors, you have a big one and a small one, and I think they will call them like major and minors, right? They call them major and minor. All right, major arc, minor arc. All right, so if we looked at this, let's look at this example here. We got a circle. And we're going to label these parts. U, V, and it's just a random S over here. I'm going to say the radius is 8, and the central angle is 70. Okay? What I would like to do is I want to find the area of the small sector and the area of the large sector. So, small sector being this part here. Alright? So, like I said before, the first thing you want to do is you want to write your givens, right? Your givens, right? Write your givens, right? So what do we have here? What do we have here?
70 degrees.
We got the angle, 70 degrees. What else do we have?
8.
The radius, 8. and then we got this given 360.
Can you like figure out the other part of the circle?
We
Would
can.
each be 140?
Say it again.
140 for each if you put like lines. The rest of that circle.
The rest of the circle.
Would it be 280 then? 140 plus 280.
Close. Yeah. You're thinking good. Close.
That's how you had his doing it.
All right. So, let's set this one up first. All right. Let's set the small sector up. So we're trying to find UV first, right? The area of UV would be what?
Area UV.
Would be what? How would we set this up?
It's 70.
70 over 360.
Okay.
Right. Look, area of the sector over the area of the circle. Area of the circle is going to be what? 64 pi. Yeah. Here we go. So we got 64 pi equals 70 over 360, right? The angle, the radius squared, r squared, 64 pi. Okay. So from here we simplify, right? 70 over 360. So let's just, and then we're gonna multiply by 64. So I just bring it over here. 70 over 360 times 64 pi.
70.
All right, 70 over 360 is what? Say it louder.
736.
736. All right. Oh, say it again.
7
Over
36.
7 over 36 times 64. All right. So we got 7 over 36 times 64 pi. Right? You're going to get a solution of roughly
39.
39.1, right?
Yep.
39.1. So you get the squiggly equal sign. Okay? So again, we're trying to find the sector, right? Over 64, that sector over the area of the circle equals the central angle divided by 360. 360 is given, right? We're gonna bring this 64 over to the other side, right? To get this sector, what we're trying to find alone by itself, all right? And then we end up with roughly 39.1. All right, now let's find the big one. So that's gonna be USV, all right? USV. If the whole circle, yes sir.
Isn't like the circle, like the other part 290?
Yes, sir. I was just finna say that. I was just finna get there. So, this angle here is 290 degrees. We all good with that? Does everybody know how we got 290?
Subtracted 270 from, or subtract 70 from
70
260.
minus 3.
Yeah, good. So it's 290, right? And we have our radius. So, the only thing that changes here is the 70 part. So, we got what we're trying to find over 64 pi, again, equals 290 over 360, right? 290 over 360, all right? So you're gonna have x equals, what's that, 29 over 36 times 64 pi.
We got 161.0.
That's your answer.
I think it's 0.1.
So you get 161 point,
161.1. I
you
mean,
got 161.1? Oh, you guys must have rounded. You must
I mean,
have
0.9.
rounded. I
Yeah.
got 9.
Yeah, that's what
Yeah.
Yeah.
Triple.
161.97, right? Does everybody get that though? So you got the big sector and the little sector. All right. What you want to do is you want to write your givens, right? Set your proportion, and then you want to solve for x. That's it. Write your givens down. What you got? Set your proportion, right? Area sector over area, angle over 360. Then solve for x. So that might incorporate cross multiplying or whatever. Okay? Alright. Let's try another one. We have a circle here. Alright? It's 40 degrees. What if they said the area of this sector is 35? So they say the area is 35. Alright? They want to know what the area of the circle is. Alright? We need one other thing. We need the we can find it. Yeah. So, again, what's our givens? What's given?
40, the measurement.
40 degrees. That's the angle.
I mean, yeah.
35.
The sector, 35 is the area of the sector, right? And then of course we got the 360, right? Duh, right? All right, so let's then next set our proportion. So we got 35 over pi r squared equals 40 over 360. Give me a head now, let me know we good with that. We good with that? All right, so then we're going to cross multiply. Let's simplify this fraction first. So we're gonna get 35 over pi r squared equals 40 over 360, which is what? 1/9, right? 1/9. To solve this proportion, you cross multiply. So you're gonna get 9 times 35 equals pi r squared. You said it's what? 315 equals pi r squared. Pi r squared is the area.
Once you divide it by r,
No,
divide
no.
by pi,
No.
you can just keep it like this.
Yeah, because we're just trying to find the area.
So then.
Pi r squared is the area. Remember? The area of a circle. Pi r squared.
Okay.
Okay? Now, okay, so what if you're trying to find the radius? What is the radius?
You divide by pi.
Alright, let's divide it by pi. 315 divided by pi equals r squared.
100.
You get what?
Wait.
You get that.
Yeah, I did it wrong.
It's 106.
Oh, that's what I did. I got
You got
it.
100 point what?
26.
100.26.
It's really
Equals.
0.27 because you're around there.
But I thought you had to do something else.
Alright. Yeah, roughly 27. So then how you get r though?
You got to divide it by
Square root.
Take the square root. So you're going to get 10 something, right? 10 point what? 0 point what?
No, 10.013.
10.013. Okay, so that's your radius, Nyla. Alright? So that's how you take it a step further because you will have a problem that will probably ask for the radius. Alright? So again, you wrote your givens, you set your proportion, solve for x. We good with this? Yeah? Let's do one more, let's do a harder one. Alright?
Oh my god.
I know, yeah. What's the last one? What time is it?
10:13.
Oh, dang.
You said.
Alright, so this is the problem you're gonna see, you might see on your homework, right? So we got the half court. Ooh, basketball. Free throw line. Okay. Oh, I woke DeMarco up. Alright. If the distance of the free throw line, if the length of the free throw line is 16, right? And the height from the baseline to the free throw line is 16, and from the free throw line to half court is 10. That's that. And then the whole baseline is 36. We want to know what the measure of the shaded region is going to be, right? So, with a problem like this, you want to pull out all the shapes you got. What shapes do we have here?
A half circle, a square,
We got a semicircle,
a square,
we got a square,
and a rectangle.
and a rectangle, right? So in essence, we're going to subtract all of these things from him. All right? What's the dimensions of this rectangle?
10. Oh, hold on.
26 by 36, right? What's the dimensions of this rectangle? 16 square, right? 16 by 16. And then this semicircle is going to be what?
It's gonna be 4, right?
So if the
It's gonna be
diameter is 16,
8.
yeah, the diameter is 16, so the radius is going to be 8, right? So for this semicircle, keep in mind, all semicircles are going to be half the area, right? So let's find them. The area of this circle is going to be what? 64 pi? 64 pi over 2, which is going to be what? 32 pi, right? The area of this square is going to be 256. Then the area of this rectangle is going to be what?
36 times
36 times 26? 936. All right? So now, we're going to subtract. So we got 936. 936, that's the big rectangle. Minus, right? The semicircle, 32 pi, plus the triangle. I keep calling the square the triangle. 256. All right. What my calculator's at?
I got 679.6.
Minus 32. 932.
That's your answer?
Yep.
You guys agree with that? I'm gonna write down what you said. 679 point who?
62.6.
Okay. I need somebody to second that.
I got 640 point.
You got 640 point what?
86.
86. All right. Anybody else?
I got 579.
I got 579.
579.
Oh my Lord Jesus.
0.5.
0.5.
Let me redo this.
I didn't put mine in the calculator like that though.
All right. So subtract. So you got this 936 minus 32 pi
Yeah,
minus 256.
I got 676.
Yeah, 676.
Yeah,
now?
my answer just changed. I don't know. Just
If you
I
do
got
the
780.5.
real number, take out the 32 pi first, you get 680, and then you subtract 32 pi,
And you get what?
57.
579.
9.5.
Right. Okay.
okay. I agree.
All right. So again, for this problem here, you got pull out the shapes that you have, pull out the given shapes, and figure out what you got to subtract. You in essence have to take this away from this rectangle. Look, you got an arch. Okay.
Lord.
All right. Cool. All right. How you feel?
Good.
For real?
Yep. I'm
All
actually
right, cool.
confident.
All right. Don't forget to like and subscribe, and if you have any questions, comment below. MrDoTheMath out.